Hello there, ladies and gentlemen, fellow discoverers. Welcome to another episode of David King's Discovery. I am your host, David King. Today, we aren't looking at one species, but multiple, as we are looking at all the dinosaurs that we know, or at least have a very good idea of, the colours of. Now, we won't be going into a lot of detail of these animals, as that would make this video far too long. And plus, I want to make videos on some of these animals anyway in the future. As well as that, we will only be focusing on mainly the non-avian dinosaurs. Whilst we do know the colour of a few more extinct avians, it would again make this video far too long. So for this video, I'll just be looking at the feathered and non-feathered, non-avian dinosaurs that we know of. Before we delve into the meat and potatoes of the video, let's quickly look at how people much smarter than me determine the colour of extinct animals. So firstly, we need an animal to fossilise. But we can't just look at the bones, we need soft tissue of an animal to fossilise. Now this is extremely rare due to soft tissue not fossilising well. When analysed, these soft tissue samples sometimes have preserved melanosomes. The size, shape and structure of these cells determine the colour of an animal. Comparing the fossilised cells to modern day cells, scientists can make educated guesses on what the colour of a dinosaur would be. Now this isn't 100% accurate, and we may never know for sure the definitive colours of these dinosaurs, but these are the best and most accurate depictions that we currently have with the resources available. We actually have some breaking news! But not entirely breaking news, depending on when this video comes out. But as I was writing this script and doing my research, in early December 2025, paleontologists discovered a potential coloration of a sauropod dinosaur, most likely Diplodocus. Looking at skin impressions, it would seem that the melanosomes were very similar to those of modern day colourful birds. Now this is the first time ever we have an idea of the colour of a large sauropod. Unfortunately, we don't know the precise coloration, but this is a huge step forward. So it's pretty crazy to me that the largest ever land animals to exist could be super colourful and multicoloured, instead of the browns and greys and greens that are seen in most portrayals. So with that breaking news out of the way, let's have a look at all the dinosaurs that we sort of know the colour of. First up on our list is Anchiornis, a small dinosaur about the size of a crow, found in China, living in the late Jurassic period, around 160 million years ago. Anchiornis would have had a body of grey and black feathers, but would have had a crown of mainly rufous-coloured feathers, which is a reddish-brown coloration, with a grey base, whilst the wings were white with black tips. Next up is Archaeopteryx. Whilst technically part of the avian family, it is one of the oldest members of the avian families, which goes against my rules at the start. However, because it is such an iconic and important dinosaur, I felt compelled to include it. Plus it's my rules, so I can break them. Archaeopteryx lived in the late Jurassic period, around 150 million years ago, in what is now South Germany, about the size of a Eurasian magpie with very well developed flight feathers. Whilst the plumage feathers are unknown, the covert feathers, which are covered by primary feathers, were completely matte black, which matches what we see in modern birds, as they lend strength to the flight feathers. Baipiosaurus is up next, a member of the Therizinosaurid genus, living in the Yishan Formation in China in the early Cretaceous period, about 130 to 122 million years ago. A relatively small dinosaur, around 2.2 meters long and weighing 27 kilograms. It was coloured predominantly in down-like feathers, with longer, simpler feathers rising out of the down feathers. Analysis from the neck feathers, it is likely that Baipiosaurus would have had reddish-brown coloured feathers. Moving quickly on to our next dinosaur, Zhaihong, a small Paravian dinosaur that lived in what is now China in the late Jurassic period, about 160 million years ago. 16 inches long, 475 grams, this tiny dinosaur would have been covered in feathers except for its snout and claws. The feathers have been found to be iridescent black, whilst on the head, chest and base of the tail, we may have seen brightly coloured feathers, similar to hummingbirds or potentially like the trumpeter. 4 down onto number 5. It is time for Caudipteryx, a small oviraptorosaurian which lived in Asia in the early Cretaceous period, around 124 million years ago. This dinosaur had very modern looking feathers, with some research suggesting that it is secondary flightless, which is when a species loses the ability of flight through evolution. The ostrich is a good example of this. Grown to sizes between 2 to 3 feet long, it would have been covered in black feathers, with a visible banding pattern on its tail. Dinosaurs is our next dinosaur, part of the Compsognathid family, and was once believed to be a Sinosauropteryx, part of the G-hole biota from the Yixian Formation in early Cretaceous period, around 125 million years ago. Around 1 meter long and covered in short feathers, these feathers would have had a rufous to chestnut colouring. The next dinosaur on our list is probably one of the more well-known, the highly important Microraptor, found in China during the early Cretaceous period, at 125 to 120 million years ago. Microraptor is one of the most abundant non-avian dinosaurs discovered, with over 300 verified fossils discovered. This dinosaur was small, but it had 4 wings, and has been found to have the capability of powered flight, with pugnacious feathers like modern birds. Microraptor have had black glossy feathers, and have also been iridescent, similar to modern-day starlings. Sinornithosaurus is next, a small feathered dromaeosaurid from the early Cretaceous period, around 124 million years ago, found in China in the Yixian Formation, and weighing only 3.5 kilograms, with a length of about 1.2 meters, so it was very small. Whilst it may have been small, there has been some speculation that this dinosaur was venomous, but that is a story for another day. With down-like feathers, which varied a lot in colour, from black feathers to rufous-coloured feathers. Only 2 more feathered dinosaurs to go, and it's now time for our favourite dinosaur, Sinosauropteryx. I've already done a much more detailed video on this dinosaur, which I'll link in the description, or at the side. It will be around somewhere. Long story short, this dinosaur had a counter-shaded pattern, with rufous and light-coloured feathers, a banded tail, and a raccoon-type mask. Now we arrive at our last feathered dinosaur, Wulong, the dancing dragon. Another dromaeosaurid from the early Cretaceous period, about 120 million years ago, from China in the Yixian Formation once again. Wulong was a small dinosaur, about the body size of a raven or a crow, but with an extremely long tail, which doubled its length to 1 meter. These dinosaurs would have had feathers that were iridescent around the fore and hind limbs, with grey feathers everywhere else. And that is all the feathered dinosaurs that we know the colour of, at least at the end of 2025. As I said in the beginning, I won't be looking into the extinct avians, but I'm not just going to leave them out completely. So here is a list of all the names of the extinct avians that we know the colours of. Some of these avians are older than the ones that we've already looked at, and some are much younger, only going extinct in the late Eocene era, so feel free to look up some of these names in your own time, as they're all fantastic and interesting to read about. So with all that out of the way, that is the end of all the feathered dinosaurs. But that's not the end of all the dinosaurs that we know the colour of, as we do know the potential colour of a few non-feathered dinosaurs. This is much more rare, as it is much more rare to get detailed soft tissue fossilisation compared to a feather. So let's take a look at some of these non-feathered dinosaurs. First up is Borealopelta, found in Alberta, Canada from the early Cretaceous period, about 113 to 100 million years ago. This dinosaur is a nodosaurid and an ankylosaur. It is also exceptionally well preserved, being fossilised in 3D, making it one of the most well preserved dinosaurs ever found. This was an incredibly large dinosaur as well, measuring 5.5 metres long and weighing an incredible 1.3 metric tons, with rows of armoured scales and spikes protruding from the shoulder blades. This dinosaur would have been reddish-brown in colour, with a counter-shaded pattern. The fact that this armoured tank of a dinosaur needed a counter-shading pattern shows how fearsome and brutal this prehistoric period was. Next up is not a specific dinosaur, but a species of dinosaur, the hadrosaurs, or more well known as the duck-billed dinosaurs, part of the Ornithischian family. This group contains such species such as Edmontosaurus and Parasaurolophus. In one fossil of a soft tissue skin impression, there was found to be the presence of eumenilin. This suggests that this family of dinosaurs could have had a grey coloration, similar to that of rhinos or elephants, meaning that the large herbivores of the dinosaur era might have had the same coloration as the large herbivores of today. Our final dinosaur is Psittacosaurus, a ceratopsian dinosaur from Asia, heralding from the early Cretaceous period, at 125 to 105 million years ago. This is an incredibly important dinosaur due to the fact it has one of the most completed dinosaur records ever, with a number of complete skeletons and fossils for most age ranges, from hatchlings to adults, meaning that we have a very in-depth view of this dinosaur compared to others. This animal would have had a counter-shaded pattern with stripes and spots on its limbs and head, similar to that of modern deer. But it also had variations of colours depending on the environment they were found in, showing, like modern animals, they adapted to their environmental conditions to better camouflage themselves. And that, my friends, brings an end to this video. I hope you have enjoyed learning a small amount about these coloured dinosaurs, and I'd highly recommend, if any of them catched your eye, to do a bit of research on them and find out a bit more, as they are all incredibly interesting in their own right. Hopefully the number of dinosaurs that we know the colour of keeps increasing, and this video one day needs to be remade with all the new additions. I hope to see you all again soon. Remember to keep learning and discovering. Until next time, goodbye.